Hi, everyone. So we start chapter 4. The section 4a of payments, the first section. So of payments means that the frequency of payments is not equal to the frequency of interest. For example, the frequency of payments is monthly, but the frequency of interest is annual. So there are two strategies to solve such kind of problems. The first method is to use the payment frequency for all cash flows and interest. So that will be covered in section 4a. So for the most cases, it's recommended method. So mostly recommended is the first one. And the second method is to use the interest earning frequency for everything. So if the payment is monthly and the interest is annual, then always use annual. So the formula becomes more complicated than the standard annuity and the perpetuity formula, but sometimes more convenient to use the annuity formula. So sometimes if we use the more than one annuity formulas, we can calculate the answer quickly. So basically, it's optimized for the calculator. And also, it's good to see that what's the difference between the payments with, the annuity with the monthly payments and annual payments. For example, the $1,000 monthly and the $12,000 annual are basically similar products. And with this method, it's easier to compare the present value of those two different products. So first one, the second methodology, the use interest earning frequency is sometimes useful when we use BA2 plus. And useful to compare present value or accumulated value of the similar annuities with different frequencies. Different frequencies. Okay, so in section 4.8, we cover the first method, the use payment frequency for all cash flows and interest. So basically, that is the similar thing to what are covered in chapter 3. Okay, so the first example. The annual effective interest rate is 3%, and $1 is paid at the end of every 5 years for 6 times. And what is the present value? So think about the time diagram first. We have 30 years in total. So t is equal to 0 is the starting point, and the end point is 30. And 1, 2, 3, 2, 5, 1, 2, 3, 4, we don't have any payment. But at t is equal to 5, the $1 is paid. At 6, 7, 8, 9, we don't have any payment. And at 10, the $1 is paid. And 15, $1 is paid. 20, paid. And 25, paid. So we only have 6 payments. And we would like to calculate the present value. So in this section, we use the payment period, payment frequency as the time unit. So I is equal to 3%, but this is annual, and they use the payment frequency. So that is 5 years. as the time unit. So payment frequency as time unit. So this is the key. Then we have to calculate the effective rate for 5 years. So effective interest rate for 5 years. So we define this as J. What is J? Then 1 plus J, this is the 5-year effective interest rate. That should be equal to 1 plus I to the 5th power because it compounds every year. So this is 1.03 to the 5th. So this is equal to 1.1593. So we will earn 15.93% interest over 5 years. So J is 1.1593 minus 1. So this is 0.1593 or 15.93%. So now that we have the interest rate J, so we can see that the present value is the 6 payments of $1. So maybe I can say the 1 times the 8 right angle 6 at this 15.93%. So by BA2 plus, you can say the 1 as payment. So 1 as payment, maybe the 1 minus as payment. And 6 as the number of payments, and the 15.93 as interest rate I over Y, we can get the $3.69. So in this way, we can solve the problem. Next example, an annuity pays the $10 at the end of each month for 5 years. So actually, we have 60 payments because 5 years of monthly payments. The effective annual interest is 6%. What is PV? So basically, this is annuity immediate with 60 payments. So at the end of each month, so annuity immediate with 60 payments. But the effective rate is given for annual rate, given as an annual rate. So we have to calculate the monthly rate. So since the payment frequency is monthly, we use that payment frequency. That is 1 month as a time unit. So this is the key. So payment unit is 1 month. Time unit is 1 month. Okay, so now that we need the monthly effective interest rate. Monthly effective interest rate as J. Then what is J? So annual rate is 6%. Annual effective rate is 6%. So that means the 1 plus J to the power 12 should be equal to the 1 plus 6%. So 6% here. So that means the J is equal to, so we make the 12th power, the 12th power, so 1.06 to the power, the 1/12 minus 1. And this becomes 0.004868, or we can say 0.4868%. So you can see that it compounds. So the this rate is a little less than the 1/12 of 6%. So now that we can think about the annuity, the present value of annuity, because if we make time unit as monthly, then we have 60 months, 1, 2, 3, up to 60. Everything is monthly, and the present value is here. And every month that we receive the $10, and the interest rate is 0.4868%. So present value of this annuity is 10 times a right angle 60 at 0.4868%. So you can just input the payment as 10 and the n as 60 and the interest rate as 0.48, then calculate the present value. Then this becomes 519.24. So in this way that we can calculate the present value of the monthly annuity.